Okay, so today we're diving into one of the boldest, most ambitious new ideas in theoretical science. It's called SORT, the Supra-Omega Resonance Theory. And it makes some absolutely staggering claims. We're talking about a theory that's supposed to be a blueprint for reality itself. So let's jump in and see what that blueprint actually looks like.
Right at the very heart of it all, SORT is asking this really profound question. What if the fundamental structure of the cosmos and the stability of a giant AI model, what if they aren't just kinda similar, but are actually two different sides of the exact same coin? Different expressions of one single mathematical blueprint.
And believe me, the ambition does not stop there. This theory is claiming that one single, unified foundation can be applied to four of the most complex and, honestly, seemingly disconnected domains in all of science. We're talking cosmology, AI safety, quantum mechanics, and even the complex systems that run our world. It's a huge claim.
So you have to be wondering, how could one theory possibly do all that? Well, to get a handle on it, we've got to look under the hood at what SORT calls its invariant core.
Now, this is a really crucial point. SORT isn't trying to throw out things like general relativity or the standard model. It's not that kind of theory. Instead, it's what's called a structural theory. It doesn't add new particles or forces. Think of it as a new layer of rules that just describes how information and structure get organized across all the different scales of the universe.
The engine driving all this really just comes down to three main parts. First up, you have the operators. These are like the Lego bricks of the system, the absolute fundamental rules. Then you've got a global projector, which is kind of like the master instruction manual that makes sure all those Lego bricks fit together perfectly. And finally, there's a projection kernel, which acts like a special lens, translating that core Lego structure into the specific language of a field, whether that's AI or quantum physics.
So how many of these fundamental building blocks, these operators, do you think it takes to build a universe? You might guess an infinite number, right? Or at least a ridiculously big one. But according to SORT, the answer is just 22. That's it. And they claim this is a complete, totally finite set. Try to add a 23rd piece, and the whole thing just falls apart.
And this leads us to what is honestly probably the most unusual and for sure the most controversial part of SORT, how it was developed. They call it pre-empirical closure, and yeah, it pretty much flips the normal scientific method on its head.
So you know how science usually works. You build a model, you test it with data, you tweak it, you test it again. While SORT did the exact opposite. The author made this very deliberate choice to build out the entire mathematical structure first, from start to finish. The whole idea is to create a complete, stable, unchangeable blueprint, and only then see how it lines up with reality. That way, you're not just testing a flexible model, you're testing the entire finished theory, warts and all.
And you can see that process right here. The project was split into two totally distinct phases, Mach version 3 and Mach version 4. The best way to think about it is that Mach v3 was the sketch phase. That's where they ran simulations just to see if these core ideas had any legs. But Mach v4, that's the final blueprint phase. It doesn't run any simulations at all. It is just the final frozen architectural design put out there for everyone to review and eventually test.
This quote from the project's own documentation just perfectly captures the whole spirit of this thing. There's this deep, almost audacious level of confidence here. They're basically saying, look, the theoretical work is done, 100%. The blueprint is finished. Now the only thing left is to see if it actually describes our reality.
All right, so with this complete but still totally untested blueprint in hand, let's finally look at how it's supposed to work in those four very different worlds.
First up, cosmology. SORT claims it can actually explain some of the biggest puzzles out there, like the Hubble tension, that nagging disagreement over how fast the universe is expanding, and also why the James Webb Telescope keeps finding these huge galaxies way earlier than our models thought possible. It says these aren't problems that need new physics. They're just projection effects of its core mathematical structure.
Now for AI, the application is incredibly relevant today. SORT proposes a way to diagnose the safety and stability of an AI system from the outside as a total black box. I mean, think about it. In an age of these massive, opaque AI models, being able to analyze the system's core structure without ever seeing its internal code, that could be a total game changer for safety and alignment. And in quantum computing, SORT offers a new way to diagnose errors and noise. And because it's a structural theory, it doesn't care about the specific hardware. The diagnostics would apply to any kind of quantum computer. It focuses on the abstract math, not the physical qubits, which, as you know, is a huge hurdle in the field right now. And finally, we have complex systems. Here, the goal is to provide a common language to analyze stability and tipping points in, well, pretty much anything, from financial markets to ecosystems to social networks. It's looking for those universal structural signs that tell you a big critical shift is about to happen, which could be an amazing early warning system.
Now, what I find really fascinating here is the real-world strategy behind all this. You can see that the core theory and the cosmology piece are being kept totally open for academic research. But the applications for AI, complex systems, and quantum systems, those are protected. That signals a very clear plan to commercialize this and use it to tackle some really high-stakes safety and infrastructure problems.
So here we are. We have a complete, wildly ambitious, multi-domain theory with a super clear development plan. But it all comes down to one thing, doesn't it? The ultimate test against cold, hard reality.
And here's just a little taste of what that test is going to look like. Back in that early exploratory phase, Mach V3, the simulation spit out a very concrete prediction for the Hubble constant. So measurements from the early universe, from the Planck satellite, suggest a value around 67, but measurements from the local universe say it's more like 73. Well, the early SORT simulation landed right at 72.79. Now let me be clear, this is not proof, it's from the old sketch phase, but it gives the final blueprint a very specific, very testable number to aim for.
The official roadmap just makes the next step crystal clear. We are right here, right now in version 6, architectural closure. The theory is done, it's frozen. The very next step, version 7, is all about empirical validation, taking this blueprint and finally running it against real-world data on some seriously powerful computers.
And that's where SORT is today. Is it a revolutionary new way of doing science? A unified blueprint for reality itself? Or is it a beautiful, fascinating, elegant mathematical idea that's about to get a very, very tough reality check? Well, the only way to find out is to run the numbers. The ultimate test is what comes next.